Hello everyone. In this pre-lecture tutorial, I'm going to introduce the concept of acids and focus primarily in how it is that we categorize acids and how we name acids of these different categories. So essentially, when you do the reading in the book that corresponds to this, they're going to explain that basically acids can be defined a number of ways. And for those of you that go on to AP Chem, and if there's time later in the year, obviously this year, we can go into those different definitions in a little bit more detail. But for now, probably the simplest way to think of an acid is a substance that when I dissolve it in water, basically produces hydrogen cations. Now keep in mind, again, we've discussed the hydrogen cation before. An example of just such a substance is hydrogen chloride or hydrogen monochloride gas. When I go and I actually dissolve this in water, what I get is I get a solution, an aqueous solution of hydrogen chloride, which further dissolves and dissociates or breaks apart into hydrogen cations and chloride anions. And so when we have these types of substances, since they behave in such a specific way, we always have to have a way of readily identifying them and naming them so that we can use them in chemical equations and study their behavior further. And so, as it turns out, there's two main types of acids. There's one category of acids that we refer to as mineral acids. And essentially, mineral acids are just acids in which I have hydrogen bonded to some other non-metal. So basically, the example I used up above is one such example. Hydrogen covalently bonded to chlorine. Or if I've got hydrogen covalently bonded to sulfur. Or if I've got hydrogen covalently bonded to fluorine. Notice that it's basically hydrogen and just one other element. These are what we actually refer to as mineral acids. However, there's another class of acids called oxyacids. And basically, it's a lot like what it sounds like. Basically, I've got hydrogen that's actually paired up with a polyatomic ion, and this polyatomic ion happens to contain oxygen. So one example would be, say, this acid, in which I'm pairing hydrogen with sulfate ion. Or I could have this, hydrogen paired with the nitrate ion. Basically, we've gone over a number of polyatomic oxyanions, and basically anytime I combine one of those polyatomic oxyanions with hydrogen, I end up with what we call an oxyacid. And so let's break down how we actually name each category of acids. So basically, as I mentioned, we have these examples that I used in the previous slide. And so in order to maintain consistency, I'm going to go ahead and use those same acids that I used in the slide before. And so basically naming these acids involves the following. Mineral acids will always have the prefix hydro. Then I'm going to go and I'm going to use the name of the anion name, and then I'm going to modify it with an IC suffix and finish off the name with the word acid. So, for example, I would start this name with the prefix hydro. This ion, if it were by itself, would be the chloride ion. Okay, but I have to modify the name so that it ends in IC, and then I would write the word acid. So this is hydrochloric acid. Here, this would be the sulfide ion. So once again, I'm going to start with the hydro prefix, and I'm going to take the anion name and I'm going to modify it so that it contains this IC suffix for the sulfide ion and also for the phosphide ion, we do that a little bit differently. In this case, we would call it hydrosulfuric acid. Okay, right here, this would be the fluoride ion. And so I'm going to start the name of this acid with the prefix hydro. I'm going to name the anion and then modify it so that it has an IC suffix, and finish off the name with the word acid. All right. One more example. Again, I mentioned this before. All right. This ion here would be the phosphide anion. And so if I were going to name this acid, I would start with the prefix hydro. Again, this would normally be identified as the phosphide anion. But again, as I mentioned before up here when I was talking about hydrosulfuric acid, we accomplish that a little bit differently for both the phosphide ion and the sulfide ion when we're trying to incorporate the IC suffix. We're going to call this hydrophosphoric acid. Okay? Now, let's contrast that with how we would actually name oxyacids. So once again, I'm going to start off with the same two acids that I identified in the first slide. Okay? Now, the important thing to understand about naming oxyacids is there's no hydro prefix. So if you're reading a description of a chemical reaction and you come across an acid name and there's no hydro prefix, that means we're dealing with an oxyacid. And I would start in a similar way to what I did when naming the mineral acids. Basically, I'm going to name it based on the anion. Okay? So this would be the sulfate anion. And so I'm going to go and I'm going to modify this name so that it contains the IC suffix that I demonstrated in the previous slide. So for sulfate, that would look like this. It would be sulfuric. All right, and to finish off the name, I would call it sulfuric acid. But if you recall with oxyanions, basically the oxyanions form families. So sulfate also has a similar ion. If you recall, this is the sulfite anion. And so I can't just call this sulfuric acid as well, because basically it would give me the same name for two different acids. I have to have a way to tell the acid apart that contains sulfate as opposed to sulfite. And the way that we accomplish this is basically I'm going to go and I'm going to modify this anion name so that basically it has an OUS suffix instead. So this would then become sulfurous acid. Okay? Works the same for essentially the nitrate ion, and if you recall, there's also a similar oxyanion to nitrate that has one less oxygen that we call the nitrite ion. And so I'm going to follow this same model that I did in the sulfuric acid and sulfurous acid examples. Basically, since this oxyanion name ends in ATE, I want to replace that with an IC suffix. So that would make this nitric acid. Okay. Now, as for the nitrite ion, basically I'm going to modify the name so that it contains an OUS suffix instead, and I would call this nitrous acid. Okay. Now, if you recall, oxyanions can also sometimes have families of 4 oxyanions. So if you remember, those elements that come from group 17 can form families of 4 oxyanions. So if you recall, and I'm going to use this as an example, I can have HClO, HClO2, HClO3, and HClO4. Now, if you recall, ClO is actually referred to as the hypochlorite anion. And much like when I encountered the ITE ending to the oxyanion name in the previous examples, what I'm going to do is replace the ITE ending of the name with an OUS suffix. And so that's going to give me the name hypochlorous acid. Okay. This oxyanion, ClO2-, would actually be the chlorite anion, and so I would refer to that as chlorous acid. ClO3- would be the chlorate anion, and so I would refer to that, if you recall, whenever I encountered the ATE ending in an oxyanion name, then basically I replaced the ATE with an IC suffix instead, and so that would make this chloric acid. And if you recall, ClO4- is referred to as the perchlorate ion, so I would refer to this as perchloric acid. Okay? So go ahead and work on the follow-up assignment that's associated with this video. Again, we'll review these rules in class, and we'll give you plenty of opportunities to practice naming these acids. Again, if you have any questions, feel free to email or speak to me in class. All right, have a good night, and I'll see you guys next class.